Here we are seeing that a circular area carrying uniform pressure. This is a circular area. We measure the stress under the from the center of the circle, the depth of the point where we measure the stress is Z. That is a denote the sigma Z actually. So here we are joining these two parts. We measure angle theta. After that we know that from Wozinek's equation del sigma Z equal to 3 dq by 2 pi z cube by z square plus r square to the power 5 by 2, where z is the distance and r is the radius of the circle and dq is the point load. Here we are seeing that there is something is a ground surface here, so here is a point load, something it is a q. Then we are right is a then the from the Wozinek equation we are writing that sigma z is equal to we are measuring the stress in this point, so sigma z is equal to sigma z, it is here from r distance and the depth of this point is z. So for Wozinek equation we are writing that sigma z equal to 3 q by 2 pi into z cube 1 by 1 plus r by z whole square to the power 5 by 2. So here this is the equation. From there we are writing that for a small load where this is a Wozinek's equation, so there is a uniform distribution of the load, and now we are measuring that what will be the stress intensity, what will be the pressure. Here the soil will be filled. So here we are taking a small strip. For integration we are always measure a small strip, or always consider small strip. So this is the small strip. So here the point, this is the distance r and this is the thickness is dr. So now the dq will be the stress intensity here q into the area. So area is 2 pi r into dr. Now we putting the value of this equation, d sigma z equal to 3 dq, sorry, q into 2 pi r into dr by 2 pi z cube by z square plus r square to the power 5 by 2. Now integrate it from 0 to this is the radius of the circle is a. Then we take the limit 0 to a, 3 cube by 2 pi into sorry, I am telling that the z cube, not it is the z cube, it is actually z square. So now we are converted in this r by z square to the power 5 by 2. So now we can integrate it. 1 plus r by z whole square. Sorry, we need not do it. If we integrate it, then 0 to a z square plus r square equal to, if we take n square, then 2r dr will 2n dn. R dr will be n dn. So now what we get 2 pi r 2 pi, so this will cancel out, and z cube is r dr by z square plus r square plus 5 by 2. Now we can change the limit of it by is r, there is r and here is n. So if the r is 0, the value of the n will be z. If the r is a, the value of the z will be z square plus a square over, so 1 by 2 to the power 1 by 2 z square plus a square, this. So 3q z cube into r dr, so now it will be n dn, and this will be n to the power 5. So now this is n to the power 4. So square 3q z cube dn by n to the power 4. So now it will be 3q z cube minus 1 by 3. Sorry, this 1 by 3 and 1 by z to the power 3 minus 1 by z square plus a square to the power 3 by 2. Now I multiply it, cube z cube. Now I multiply it with z cube, so 1 minus z cube by z square plus a square to the power 3 by 2 equal to 1 minus 1 by 1 plus a by z whole square to the power 3 by 2. Now I get the equation. Then sigma z will be q stress intensity 1 minus 1 by 1 plus q by 1 a by z whole square per 3 by 2. Now we consider, now here we are coming to Newmark's chart. So sorry, for Newmark's chart we know that for circle with the stress intensity will be sigma z, and here is another circle which is actually the concentric circle. So for this whole circle the stress intensity will be 2 sigma z, and if I take the strip, for strip intensity will be 2 sigma z minus sigma z, then it comes up to sigma z. So here we assume that sigma z by q equal to 0.1. So sigma z equal to, we know that from the equation here we are getting that, so 1 minus 1 by 1 plus a by z whole square to the power 3 by 2. If I put this sigma z by q equal to 1, so 0.1, so what is the value of it you can get. We are showing that if I equating this, then we get a by z will be 0.27 and a will be 0.1. 0.27 z. So what is the meaning of that? If there is a uniform stress distribution in a constant in a circle, then in circular shape, infinite loaded circular area, then the stress and then the radius of it will be measuring the stress intensity below the depth of z from the infinite loaded area, and we get the value of the sigma z. If the sigma z by q equal to 0.1, then the value of the radius will be value of the radius will be 0.27 times of the z. It is a simple answer. And now if we take sigma z by q, a by z 0 0, sigma z, if we put in sigma z by q equal to 0, then a by z, the value will be a by z will be 0. After that 0.1 will be 0.27 and 0.2, 0.40, 0.3, 0.52 and so on. So one for 1.0 is infinity. So here we get a number of concentric circles. We get a number of concentric circles which radius will be 0.27 into z, after that 0.40 into z, and just like that, and after that is 0.52 into z. Just go on, such go on. This is the whole chart. Just look into it. Consider it 0 for the point 0, 0.1 it will be 0.27, and this is the sigma z by q value, and this is the a by z value. I can get all of this value from this equation. Here is the mathematics that a rectangular area 2 by 4 carries a uniform load at 80 kN per meter square at the GL. Find the vertical pressure at 5 meter below the center of the loaded area. Sigma z, we know that for circular, or we are drawing the Newmark chart. So we know that from Newmark chart is a circularly loaded area. So from circularly loaded area, we know that it is sigma z is equal to q into 1 minus 1 by 1 plus a by z to the power 2 whole to the power 3 by 2. From there sigma z by q, we are getting that 0.1, 0.2, by putting the 0.1, 0.2, 0.3, so we get 0, 0.27, 0.40, 0.2, like that, and so on. And we know that the z equal to 5 because it is 5 meter below. Actually there is like that, that is the 2, there is a 4, 2 meter by 4 meter. So this is 2 meter, this is 4 meter. So we should measure the load at the below the center of the loaded area. So this is the loaded area portion. We find this value, find the sigma z value from the Newmark chart. So so here from there we are measuring that we take from question we see that we measure the sigma z value in the center. So here we know that there is a circular loaded area Newmark chart actually shows. So from here we are measuring the center, so we put the center of the uh, rectangular area here, and we draw it by proper measurement. So here we are draw it and after that there will be more circular area, circles also. There is 1 2 3 4 5 6 7 8 9 actually. So from there will be, we are cutting this portion into equally. This will be 5 sectors, equally 5 sectors in each of the 4 coordinates, each coordinates of the 4. And we know that from bosonic equation that sigma z by for sigma z value 1 minus 1 plus a by z, there are 20 sectors. We cut each coordinates into 5 equal sectors. So here we have total 20 sectors. So we taking for each sector, this will be q by 20 and this will be sigma z by 20 for each sectors, sigma z value, and this will be 1 minus 1 by 1 plus a by z whole square 3 by 2 this. So by putting the value a by z equal to 0.27, we can get the value 0.1 by 20 into q. From there we are getting the 0.005 q, the value of each segment of sigma z. This will be 0.005 into q. By getting this value, now we know that the total stress will be in, actually this is the influence factor, if influence factor. So if into q into number of full segments, and measures here the number of full segments, and we can get, actually if we draw the circles in a millimeter graph paper by taking 5 meter equal to 5 centimeter, 5 meter 5 centimeter, then 1 meter equal to 1 centimeter. So 1 is to 100 scale, 1 is to 100 scale, then we get the Newmark chart values, and from there we are getting that from if value it will be 0.005, and q, this is from our question that 80 kilonewton per meter square. So 80 into the full segments, if you draw it, then you get the number of full segments will be total 80 segments, so the value will be coming 9.6 kilonewton per meter square. And the question can be done by other methods, or bosonic approximate method also. If we take that, this is the rectangular area 2 by 4. So we measure it here, sigma z at the center point. So these are 4 equal parts, so we take one part. From bosonic equation we know that sigma z value equal to 3q by 2 pi, and q is the actual point load. Here it is a distributed load, so we convert it as a point load. Q equal to, for one segment, for one segment it will be, q value will be 80 kilonewton per meter square. So 80 into it will be 2 by 1. So this is 1 meter, and this is the whole, this is the 2 meter, and this is the whole, this is the 4 meter, and this is the 2 meter. So 2 into 1, and it is 160 kilonewton. So the point load is will be passing through the middle of this portion. We know that from the center of gravity of this portion. And the R value now, the formulation will be into z square into 1 by r by z whole square to the power 5 by 2. So here the R value will be, we measure the sigma z value from this point under this, from this is actually, if we showing this is actually this types of sheet where the uniform unloaded portion, and this point we measure the sigma z value under it 5 meter. So the z value is actually 5 meter. So we 3 into 160 by 2 pi into 5 square 1 plus r. Now r value will be measured from, we actually get the point load here. So we measure the sigma z value from here to here. So we join this portion, and this is our r value. So what will be the r value? This, if we know that this portion, and we know that this portion. So this is will be 1 by this is 1 by 2. So this will be 0.5, and this will be 2 by 1. This will be 1. So r equal to 1 square plus 0.5 whole square root over. So we get the value of the r, and r by z, and this will be 1 square plus 0.5 whole square by z square, and z square 5 square. And if we putting those values, we can get the value 2.705 kilonewton per meter square. Now we get the value of sigma z for one segment only. So there is 4 segments. So we get the total value of sigma z will be 2.705 into 4 kilonewton per meter square. It will be 10.819 kilonewton per meter square. So the value of the 9.6 meter. So somehow it is deeper, but from actually the Newmark chart, we can also measure the value of the sigma z value. Also it is little bit differ, but it is almost right. So how we can get sigma z value? By Newmark chart, and also approximate Bose-Riggs method or twist one method. So it's near to it.